In question number 1 of this third exercise, we have been asked to name any two figures that have both line and rotational symmetry. So let us see what are those two figures. So the first figure is an equilateral triangle which has both line and rotational symmetry, and the second figure is a circle which again has both line and rotational symmetry. So if we consider the equilateral triangle which is given in this figure, this one, so these are the three lines of symmetry for an equilateral triangle which will pass through the three vertices, and all these three lines individually can divide the equilateral triangle into equal halves. And if you fold the figure along any of these lines, you'll see that both the equal halves will coincide. Now moving on to the rotational symmetry part, if I mark this point of the figure as a blue dot to visualize the rotation, when this figure is rotated by 60 degrees in the clockwise direction, let us now see what would be the new position after the rotation of this blue dot. So after a rotation of 60 degrees, we can see that the blue dot is here, which shows the rotation of this figure, even if the figure is the same as is in the question figure. If we again rotate this figure by 60 degrees in the clockwise direction, let us now see what would be the new position of this blue dot. So rotating the question figure by 120 degrees will result in this position of the blue dot, which again will give us a figure which is similar to the question figure, but yes, it has underwent rotation, because of which the blue dot is now here. Again, if we rotate this figure by 60 degrees in the clockwise direction, we'll again see that the blue dot will go back to the position where it is in the first figure. So an equilateral triangle has both line and rotational symmetry. Now in a circle, we have that a circle is the most perfect symmetrical figure because it can be rotated around its center through any angle, and at the same time it has unlimited number of lines of symmetry. So if I consider these lines, where if we say that these lines meet at this point, which is the center of the circle, and all these are diameters, we can say that a circle forms line symmetry with its every diameter, and it has rotational symmetry around the center for every angle. So a circle is also a figure which has both line and rotational symmetry. And this is how we'll answer the first question of this exercise.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.